Hello everyone, I am Mayur Vasoya, fourth semester student of Master in Construction Engineering and Management at CEPT University, and I will be the give presentation on my DRP topic, Equipment Productivity and Utilization Monitoring, under the guidance of Mr. Deep Shah, who is a Senior General Manager of Business Development and Tendering Department at Riviera Infra Project and Private Limited. This research is a focus on understanding how efficiently construction equipment is used on high-rise building project and how productivity loss can be reduced through better planning, monitoring, and maintenance practices. In construction project, equipment play a major role in improving speed, safety, and overall work efficiency. However, only having equipment available on site does not guarantee productivity. The actual benefit depends on how well the equipment is planned, deployed, operated, monitored, and maintained. So now move on the next slide. This slide also presents the main DRP deliverables: introduction, literature review, research, methodology, data collection, data analysis, and conclusion. This structure represents the complete research journey. First, I establish the background and need for the study. Then, I review existing literature, developed the methodology, collected the site and survey data, analyzed the result, and finally proposed improvement measures. The central part of the slide explains the step in equipment productivity and utilization monitoring. The process starts with the equipment planning, where suitable equipment is selected based on project requirement, capacity, and site coordination. After that comes equipment deployment and operation, where the selected machines are used for the site activity such as the lifting, concrete plastering, material movement, and reinforcement processing. The next step is the performance monitoring, where the working hours, idle time, output, and efficiency and tracked. It can be do using the mobile app, CCTV, sensor, or telematic system. After the monitoring, idle time is identified, and the idle time means the equipment is available but not doing productive work due to the waiting for material and breakdowns, poor coordination, or work from delays. Finally, the collected data is analyzed to identify inefficiency and take corrective action, such as the improved scheduling, maintenance planning, and better coordination between the site team. So, the main idea of this research is the equipment productivity can be improved only when the equipment use is monitoring continuously and decisions are taken based on the actual site data. And you see the our DRP schedule. So commitment report and initial planning are January month, then the February month literature study, and the all are DRP complete. The submission of the DRP report in May. So after the introduction the topic and the overall research flow, I will now explain the purpose, objective, and expected outcome of this study. So now move on the introduction part. And the purpose of the study comes from the rapid growth of high-rise construction in India. As buildings become taller and project timelines become lighter, construction sites are becoming more dependent on heavy equipment. Equipment like tower crane, hoist, boom placer, and rebar machine are no longer optional support system. They are initial for the daily progress. However, the inefficient equipment usage often lead to delays and cost overruns. For example, if the tower crane is available but cannot operate due to the poor scheduling or material unavailability, then the project lose productive time. Similarly, if the boom pressure is ready but concrete supply is delayed, it utilizes and reduce. These small operational gaps accumulate and affect the overall project schedule. The objectives are divided into three important parts. The first objective is to identify the most influencing factor affecting the equipment productivity and utilization. These are the factors that have a major effect of equipment performance and need immediate attention. The second objective is to identify the least influencing factor. This is also useful because it helps the project team avoid spending too much time on low impact issue and instead focus on high property progress. And the third objective is to propose actionable measures. The purpose of the research is not only to rank factor but also to suggest practical strategy that can reduce idle time, delays, and improve all overall equipment utilization. The expected outcomes the also shown on the slide, the study aimed to develop a clear understanding of productivity related factors, identifying the rank key factor using the relative important index method, suggest strategic measures, and provide real site based insight. Overall, this slide sets the direction of the research. It explains that the study is focused on practical improvement of equipment productivity and not only on theoretical discussion. So, once the purpose and objective were defined, the next step was to study existing research and understand what previous study have already identified about equipment productivity and monitoring. So now move on the literature review. The first theme shown on the slide is urbanization and equipment demand. Due to the rapid urban growth, high-rise construction has increased significantly. This creates a greater dependency on equipment because vertically construction requires continuous lifting, material movement, concrete passing, and reinforcement handling in the such a project. Equipment failure or idle time then immediately affect the site progress. Now, second is the equipment productivity challenges. Literature show that the frequent breakdowns, improper planning, poor scheduling, and idle time are common reason for the productivity. And machine may be the technical capable, but if it is not planned properly, its output remains limited. The third one is the utilization efficiency. So, in linked with the workflow continuously, for example, if the main material hose is not available at the required time, labor and small material movement gets delayed. If bar bending and cutting machine are not working, efficiently reinforcement work may slow down, which further affect the sorting and concreting activities. The slide also highlights digital monitoring technology such as the CCTV mobile apps, IoT sensors, and telematic system. This technology help in improving tracking and reducing dependency on manual record. And traditional lookbooks and site register are useful but have limitation because they depend on manual entries and may not capture real-time condition accurately. Another important theme is productivity loss factor. Literature identifies the material delay, coordination gap, unskilled operator, weak supervision, poor maintenance practice are interconnected. For example, if material is delayed, equipment becomes idle. If coordination is weak, the operator may not receive clear instruction. If preventive maintenance is not done, small technical issue may become major breakdowns. On the right side, the literature follow also connect site management and urbanization pressure, maintenance and idle time, and poor coordination and planning increase the idle time, limited site space affect the movement and positioning of equipment, and lack of the preventive maintenance lead to breakdowns. The key insight from the literature is this connect continuous monitoring plus proper planning lead to improve utilization. And this means productivity improvement is not only about using advanced equipment. It requires a complete system of planning, monitoring, maintenance, and coordination. And the inference from the literature review is that idle time is one of the biggest contributor to productivity loss. Therefore, the shift from manual monitoring to digital and data-driven monitoring is necessary for the improving equipment performance in modern high-rise construction projects. Based on the literature review, the major factors were identified and a structure research methodology was prepared to collect and analyze the data from the actual construction. So now move on the research methodology. The research methodology defines the structure process follow for the connecting this duty. For this research, I adopted a quantitative and field-based approach, supported by literature review, questionnaire survey, site observation, equipment logs, and data analysis. The methodology process is divided into four major stages. The first stage is identified of the factor. In this stage, I review literature and study actual site practice to identify the factor affecting equipment productivity and utilization. And this factor included equipment breakdowns, poor scheduling, lack of maintenance, material delay, operator skill, and monitoring frequency. The second stage is questionized preparation. After identify the factor, similar factors were combined and categorized. Then a structure questionnaire was prepared using a Likert scale. The Likert scale helped respondent rate each factor from very low impact to very high impact. And this made it possible to convert professional opinions into measurable data. The third stage is data collection and analysis. Data was collected through site visit, questionnaire response, equipment logs, and site engineers, and equipment operators. After collecting the response, the data was analyzed using the relative importance index method. So RRI helped rank the factor based on their impact level. The fourth stage is conclusion and improvement suggestion. Based on the analysis, practical recommendations were proposed to improve equipment productivity and utilization. These recommendations focus on better scheduling, preventive maintenance, operator training, digital monitoring, and coordination between site teams. So, this methodology is important because it connects academic research with practical site condition. The study does not depend only one theoretical sources. It uses actual site data and professional responses to understand to real-time equipment and related problems. And the inference from the slide is that research methodology provide a clear path from problem identification to practical recommendation. It ensures that the final conclusion are based on structured data and not only a assumption. So after finalize the methodology, the next step was the collecting both primary and secondary data related to equipment productivity and utilization. So now move on the data collection. This slide explains the data collection framework used in the study, and data was collected through two main sources, primary data and secondary data. Primary data was collected through site visit, discussion with project manager and planning engineer. This data help in understanding actual equipment use, site level problem, and professional opinion about productivity loss. Secondary data was collected through the literature review and previous research study. This helps is identify the important factor affecting equipment productivity and utilization before the preparing the questionnaire. The data collection process shown on the slide explain how is the study moved from the board research undertaking to site-based analysis. From the literature review, a total of 60 factors were identified. These factors were then categorized into four groups: equipment related, management related, site related, and operator related. So, equipment related factor included breakdowns, lack of preventive maintenance, electric, cable fault, equipment age, and management related are in poor scheduling, weak supervision. Site related means factor including material supply delay, work from not being ready, and site life constraint. And operator related factor including unskilled operator and lack of technical use. The slide also explains the primary data collection through questionnaire and survey on site, and responded were asked to rate two factors using a 1 to 5 Likert scale, when 1 means very low impact and 5 means very high impact. The purpose of collecting data was the understanding not only the where problem exists, but also how strongly each problem affects the equipment productivity and utilization. The inference is the data collection approach combine literature-based factor identification with real site observation and professional judgment. And this makes the study more practical and relevant for construction site management. So after understanding the overall data collection process, I will now explain the selected equipment, their working hour, utilization level, and breakdown observation. So now move on the data collection second slide. This slide represents the site-based data collected for the selected equipment. The equipment study including tower crane, boom placer, main material hoist, bar bending machine, and bar cutting machine. Each of these machines has a specific role in high-rise construction. The tower crane is used for lifting and shifting materials vertically and horizontally. The boom placer is used for concrete tracing and especially during slab casting and core wall work. And the MMH is used for the vertical movement of workers and small material. Bar bending and bar cutting machine are used for reinforcement and preparation. The site present the actual working hours and utilization of this equipment. The tower crane was available for 10 hours and worked for 7 hours, giving 70% utilization. Same, the boom placer was available for 12 hours on casting days and worked for 8 hours, giving 67% utilization. And the MMH was available for 10 hours and worked for 7 hours, giving 70% utilization. And this value shows the equipment utilization range between 67% and 72%, which indicate moderate efficiency. However, it also means that a significant portion of available time is lost due to the idle time, waiting time, breakdowns, material delays, or coordination gap. The slide also present the factor identified under four category: equipment, equipment related, included frequent breakdowns and cable fault, electrical and equipment edge or technology gap, management and planning related issue include poor scheduling, material supply delay. This issue reduce productivity even when the equipment itself is functional. And operator related issue including unskilled operator and lack of the technical training. And monitoring related issue include weak supervision and absence of proper monitoring system. If equipment performance is not tracked regularly, idle time remain high and corrective action get delayed. The breakdown logs on the slide further support their finding. The tower crane recording the highest number of breakdown in region, mainly due to the cable joint issue, voltage problem, trolley cable damage, jumping work, and hosting wire rope problems. Bar bending and bar cutting machine had favor issues, mainly related to connection problems and blade damage. The important learning from the breakdown log is that downtime is not always caused by one major failure. Repeated small issues like cable pull, voltage fluctuation, and connection problems can also reduce equipment productivity. And the inference is the equipment utilization is moderate, but there is a clear scope for improvement, better scheduling, preventive maintenance, and coordination between operator and site team can help reduce idle time and increase productivity. After studying actually working hours and breakdown data, the next step is to analyze the survey response and understand which factors are considered most critical by construction professionals. So now move on the next slide. This slide introduces the data analysis part of the study. Quantitative data was collected through a questionnaire survey conducted at construction site in these two cities. The respondent included a project manager, planning engineer, and site engineer. These respondents were selected because they directly involved in the equipment planning and deployment and daily monitoring and coordination. Their response help understanding the practical factor affecting productivity from a contractor side perspective. The survey used to 1 to 5 Likert scale. In this scale, 1 present very low impact, 2 present low impact, 3 present moderate impact, 4 represent high impact, and 5 represent very high impact. This help convert the experience-based opinion into measurable data. The slide also present the questionnaire survey assumption. The geographical scope included Ahmedabad and surrounding area, and the study focused in high-rise building construction site. The perspective is from the project manager and the planning engineer. The site structure represents the equipment intensive work from where machinery play a major role in the construction progress. The slide also including improvement finding related to digital monitoring. A review frequency in the digital monitoring tools. CCTV monitoring was preferred by 33% of responded and the followed by mobile app at 27%, sensor-based telematic at 26 and GPS tracking at 40. These trends show that professional prefer tools that are practical and easy to apply on site. CCTV help in visually checking whether equipment is working or idle. Mobile app log help replace the manual register and allow faster recording of equipment data. Sensor-based telematic is useful but may require more technical knowledge. And GPS Trekking is less prepared in high-rise building project because equipment like cranes and hoist are mostly fixed or operated within limited area. And the review frequency data so that the weekly review was prepared by 40%, daily review by 29, and real-time review by 26, and monthly review by only 5%. This means the monthly review is too delay for high-rise construction, where work front and equipment need change quickly. The inference from this slide is that equipment productivity is mainly affected by the improper scheduling, site layout constraint, equipment age, poor coordination, and unskilled operator. Digital tools like CCTV and mobile apps log can help tracking idle time, but regular daily or weekly review is needed to the take corrective action on time. To rank this factor properly, the relevant important index method was applied, and the next slide explains the RRI calculation and overall ranking of factor. So now move on the next slide. The RRI method is useful when survey responses are collected using a Likert scale. It converts the response into the numerical index, which help compare the different factor on common scale. A higher RRI value means that the factor has a stronger influence on equipment productivity and utilization. The RRI formula used in the study is RRI sigma W upon the A into N. Here, sigma W is the total weight assigned by all respondents. A is the maximal possible score, which is the 5 in this study, and N is the total number of respondents. In this research, respondents were the collected from the 73 respondents, and the slide represent the overall ranking of factor. The highest rank factor is improper scheduling with an RRI value of 0.772. This means poor scheduling of equipment is daily work plan is the most critical issue. If equipment is deployment without checking material availability, labor availability, or work front readiness, the machine remained idle. The second rank factor is site layout and space constraint with an RRI value of 0.764. High-rise construction sites often have limited space, and poor layout can restrict movement, create congestion, and reduce equipment efficiency. The third rank factor is equipment age and technology gap with an RRI value of 0.751. So older equipment may have a more breakdowns, lower efficiency, and limited monitoring capability compared to modern machines. The moderate influence factor include poor site conditions, unskilled operator, availability of spare part, work for availability, material supply, data driven decision making, MMH operational waiting time, tower crane jumping and maintenance, bar machine mechanical wear, and monitoring frequency. These low influence factor included tower crane electrical and cable issue and boom placer setup and cleaning. These factors are still important, but compared to scheduling and site layout, the overall impact is lower according to RRI ranking. The slide also shows the inclusion level classification. Factors which RRI above 0.75 are classified a high influence, factor between 0.65 to 0.75 are moderate influence, and factors below 0.65 are low influence. The most important inference from this slide is the top ranking factors are not only technical problem, they are mainly related to planning, coordination, site layout, and management. This means that equipment productivity can be improved significantly by improved planning, system, site coordination, operator training, and monitoring practice. After the identify the most critical factor, the next step is to convert these findings into a practical action plan for improving equipment and utilization. So now move on the strategic action plan for the improvement equipment utilization. This slide represents the strategic action plan development from the data analysis and RRI ranking. The purpose of this action plan is to convert the research finding into practical measures that can be applied on construction site. The first action area is improve planning and scheduling. Improvement planning was the highest rank RRI value 0.772 and site layout constraint ranked second with the RRI value of 0.764. To address this, project team should prepare weekly equipment development plans. Equipment schedule for the crane MMH boom pressure and rebar machine should be linked with actual work front availability. The second area is used digital monitoring tool. CCTV monitoring was preferred by 33% of responded and mobile app log were preferred by 27%. This tool can be help take the idle equipment, reduce manually register and record working hour, idle time and breakdown time more accurately. The third action area is state operator training. Lack of the technical expertise was identified by 59% of the responded as the main barrier to digital monitoring. An unskilled operator had a RRI value of 0.747. This means equipment improvement cannot happen only through machine or software. Operator and engineer must be trained to use equipment efficiently, interpret monitoring data properly. And the fourth action area is improve maintenance system. The breakdown log show repair tower crane issue related to cable zone, voltage problem, trolley damage, and jumping work. To reduce this failure, preventive maintenance checklist should be prepared, and the cable joint, motor blade, and connection should be checked regularly, and the critical spare parts should be available on site, and maintenance should be planned during non-working hour where possible. The fifth action area is improve site coordination. Poor site coordination had a RRI value of 0.748 and the work fund availability had an RRI value of 0.712. To address this daily coordination meeting between the planning team, site team and equipment operators should be connected. So before the equipment deployment, the team should confirm material availability, labor readiness and work front clearance. The overall inference is that equipment productivity can be improved by combined planning, monitoring, maintenance, training, and coordination. Since the most major issues are connected to planning and coordination, site teams should be focused on reducing idle time through the structured design, making, and regular monitoring. After the presenting the strategic action plan, I will now conduct the study and discuss the future scope for further research. So now move on the conclusion. The study conclude that the equipment productivity and utilization are important for improving time performance, cost efficiency, and workflow continuity in high-rise construction projects. The selected equipment, tower crane, boom placer, main material hose, and bar bending and cutting machine directly affect the site progress because each machine supported a critical construction activity. The site data should be the equipment utilization rate between 65 to 75. This indicates moderate efficiency, but is also so that a considered amount of available equipment time is lost due to the idle time, breakdowns, and coordination gap. The RRI analysis they help identify the most critical influence factor. The top three factors were improper scheduling, site layout, space constraint, and equipment age or technology gap. This finding show that equipment productivity loss is not only due to the machine failure, it is strongly connected with the management practice, planning system, work front readiness, and site coordination. The study also found that the digital monitoring tools can support better equipment management. CCTV monitoring and mobile apps logs were preferred because they are practical and easier to implement. And the breakdown log showed that tower crane experienced the highest number of breakdowns, especially due to the cable voltage, trolley, and jumping related issue. And the final conclusion is that equipment utilization can be improved through better planning, proper scheduling, preventive maintenance, skill operator training, digital monitoring, and regular performance review. The future scope of the study included a detailed time motion study for the each equipment. Such study can identify exact productive and non productive time. A cost benefit analysis can gap also be done to compare CCTV, mobile gaps, GPS, and sensor based telematics. Future research can also explore beam-based equipment planning, where equipment location, movement, path, and site layout can be planned before actual execution. And the study can also be extended to more site and different types of project for wider applicability. Financial analysis can also be included to measure cost saving uh, achieved by reducing idle time and improve equipment utilization. To conclude, improve equipment productivity is not only about using better machine. It requires proper planning, trained manpower, preventive maintenance, digital monitoring, and strong coordination. If these measures are implemented properly, construction site can reduce idle time, improve utilization, and complete work more efficiently. With this, I conclude my presentation on equipment productivity and utilization monitoring. Thank you for your time and attention.